Good morning, everybody. For part 2 of similar triangles, we are going to look at applying that idea of ratios to some problems that have a little bit of algebra in them, but also problems where the diagrams are a little more involved than having just two separate ones. So on this first slide, I just wanted to show you, like, these are the ones that we did on the last assignment, right? So you can see that you have two figures that are similar and they're completely separate figures, and the most exciting your missing value gets is an x, right? So here in this one they said that the scale factor is 2 to 3. So if you have your pen, we say 2 to 3 must equal 42 to x, and we can solve by cross multiplying, or you could figure out, well, I told you the scale factor. And again, they're all of these problems on this page are like that. The x and the 28 are the sides that line up. They gave us the scale factor. And those are the ones that we did last week. But what I want to look at now are ones where there's a little more algebra involved. So you will notice in numbers 8 and 9 here, they tell us that the two triangles are similar. And they want us to find the value of x, but now instead of just an x, there's an x plus 6 here, and there's an x plus 3 here. So the first thing we have to do is figure out which sides line up with which sides so that we can get our proportions set up. So let's see. This here is side AG, right? This 32 right here is side AG. So if visually I'm not sure which sides line up, I'm going to always go back to my names. So AG must match up with KX because of those are both the first two letters in the names. So AG, which is 32, has to be matching up with KX, which is x plus 3. So there's a ratio. Please resist the urge to say that they're equal. They're not. If those were congruent triangles, we would be saying they're equal. They're not congruent. So what we're doing now is we're taking the sides that match up and we're putting them in a ratio. Okay. Here we have side GM. All right, there's GM. GM is 36, and as you can see in the name, GM is the last two letters. So the last two letters over here is XD. So I know that 36 and x plus 6 must belong in a ratio together. And since I know they're similar, I know those ratios are equal. Now, some of you asked me last week, I got this question several times, if you had to set up the proportion and solve it with algebra, or if you could just figure out what the numbers were and go from there. And my answer was, you don't have to do a proportion, right? You can just figure out what the ratio is and go from there. But when you have a problem like this, you can't do that, right? So it's in a problem like this where there's more than one x involved, where we're going to have to solve the proportion. So I wanted to go over one, the setup with that with you, but also I just want to go through how to solve it again because, you know, it looks intimidating when we get x's in it. So we're going to do a cross multiplication. So I'm going to take this 32 and multiply it by x plus 6. Note my use of parentheses because I'm multiplying by this whole quantity x plus 6, and therefore I'm going to have to distribute. And then I'm going to do 36 times x plus 3 on this side. Okay. So now what I have is an equation. I'm sneaking my calculator just in case. Now I have an equation I can solve, but this equation is not going to be super fun to solve because it's got, well, it is going to be super fun, let's not lie, but it's not going to be real quick because we have two distributions to do. So on the left, if we do our distribution, we have 32x plus 32 times 6, which I just figured out is 192. I don't trust my mental math. And then on the other side, I have 36 times x, which is 36x, and 36 times 3, which is 90. I think that's 108. Should we check it? 36 times 3. Boom, 108. So now this isn't just a simple one-step equation anymore, right? I've got a little bit of work to do if I want to solve this. So for me, I'm going to move the 36x to both sides, or take the 36x off both sides. I'm doing my seesaw thing, right? So over on the left-hand side, I'm going to have a negative 4x plus 192 and a 108. And then I have a plus 192, so I'm going to do a minus 192 on both sides. Now I have negative 4x is equal to, let's see, 108 minus 192. Whoa. Okay, I didn't do it right. 108 minus 192. See, I don't trust my mental math. I don't even trust my calculator math. I got an 84, negative 84. So last step, as always, we divide by negative 4, and I get that x equals 21. Now I can check that by saying, okay, well, if x is 21, then this side would be 24, and this side would be 27. And you could make sure those two ratios are the same. Right? So if I do 32 over 24, I get 1.3 repeating. I better be able to do 36 over 27 and also get 1.3 repeating. Otherwise, I've got a wrong answer here. 36 divided by 27. I'm going to show you. 1, can you see it, or is it all glared? 1.3 repeating. So we've got a right answer. Okay. So the avoidance of algebra is no longer an option. You're going to have to cross multiply and solve those equations out. Just remember you can use DCMCS every time, or whatever method you learned for solving equations. Seesaw, teeter-totter, whatever you want to call it. All right, let's do number 9. I have this side right here, TL, which is a 25. And by looking at the names, CH should be its partner. So CH. All right, so I have a ratio, 25 over 10. I have a 4x minus 1, and that's my LY. So HK should be its partner, and luckily I have it. So my other ratio is 4x minus 1 over x plus 5. Notice I'm being really careful with my ratios here. I'm going big on top, little on the bottom, big on top, little on the bottom. It doesn't matter which way you do it, but you have to do them both in the same way. All right, do a cross multiply. I tried to change my color. Okay, so on the left, I'm going to have 25 times x plus 5. Again, the parentheses are key. If you forget the parentheses, you will not have the right equation. And on the right-hand side, I'm going to have 10 and 4x minus 1. So we'll do a little distribution here. 25x plus 125. And a little distribution here. 40x minus 10. And then we can start moving some terms around. What do you want to move, Feynman? Feynman wants to move the 40x. He says that he doesn't like having his variables on the right side. I agree, Feynman. You are a very smart cat. So that means that I now have a negative 15x plus 125 on this side and a negative 10 on this side. And since Feynman made the executive decision to pull that x to the left, now we have no choice but to pull this 125 to the right. Okay, so now I have a negative 15x, and on the other side, I have a negative 135. So we're going to divide out by negative 15, and we get 9. Okay, so you're going to see some on the homework that are like this, that have more than just one x, and it's like an expression in terms of x instead of just an x, and the idea has not changed. We still have the proportions that we need to set up. They're just a little bit more involved once those are there. The other thing that I want to show you that I want you to practice this week is when the diagrams, instead of being like two distinct different shapes, are kind of attached. And you probably remember this from congruency, when they kind of do this little thing where they join them together with vertical angles or something like that. And so that's absolutely happening here. So they didn't give us a similarity statement here, but what I want you to see is that literally if you took this triangle, this yellow one, and literally just flipped it. Oh my. I flipped it up. You would have like two back-to-back similar triangles. Oh my goodness. It's not a day if I don't have trouble with my whiteboard. All right, so we need to find the pairs that match up. So you see this flat side right here? It's gonna line up with this flat side over here. So there's my first ratio. So my first ratio is 18 over 27, or you could write 27 over 18. Doesn't matter to me. I'm going to write 18 over 27. Okay, so now across, we can see here that this side too, especially if we flip them up, that side there, TU, would correspond with UV. And that's nice, but I don't have any numbers or any givens on there. The good news is that helps me to see that this x plus 2 would line up with this 20. So since I did 18 over 27, my other ratio is going to be 20 over x plus 2. And I'm going to cross multiply and finish this baby. So I'm going to have 18 times x plus 2 on one side and 27 times 20 on the other side. So that's 18x plus 36, and I should know this. 540. I was going to say 440 and I would have embarrassed myself. Good thing I didn't. All right. So this one isn't too bad because you only have x on one side. So let's take the 36 off of both sides. I have 18x, 504. And when I divide that out, I get that x is 28, which would make this side a 30. Oh my. 30. Oh my. I am going to be a YouTube sensation. Oh my God. There we go. Okay, so, oh my goodness. Again, 18 to 27, if I divide that out, 18 over 27 gives me a ratio of 0.6 repeating. If I take these two and divide them out, 20 over 30 also gives me a ratio of 0.6 repeating. Because those match, I know I did it correctly. So when you do these ratios and when you solve these proportions, when you end up with numbers for answers, you can always just divide them out and see if they don't match. If your ratios don't match, then something's wrong. You probably just set up your sides in the wrong pairs. Okay, the last kind I want to show you, even though I've already accidentally shown it to you like 5 times now, is when they do this trick where it looks like one shape, but they're being sneaky and they stuck one triangle inside of another triangle. You see that? So in this case, we have this triangle, oh my, the blue triangle, the outer triangle, which I'm calling the big triangle. It has this big long side, which is 15, and this big long side, you can tell I made up this question, which is going to add up these two chunks to 30. Okay. Then, is this a joke? Does somebody have my remote and you're like outside? I really can't. Okay. All right. Now, because of this horizontal line here, you've got this big blue triangle, but because of this horizontal line right here, what they do is they cut the top off a big blue triangle and created, like, I'm not even kidding. Gary Reagan is outside my house and he's messing with me. I just want to go back to school. I just want to go back to school. Can you just... Okay. All right. So what we have here, if I can stay on this slide, is a pair of similar triangles where it's like a little triangle that's inside of a big triangle. So we can still, if you wanted to, you could kind of pull them apart and draw them separately, but we don't really need to. As long as we can make two ratios, like small to big, which is how I'm going to do it. I'm going to do small over big. Okay, so if I look at this left-hand side, the small side is x plus 1, the purple side. The big triangle has a side of 15. If I look at this side of the triangle, my small triangle, the purple one, has a side length of 12. My big triangle is this whole big side, the 12 and the 18, which adds up to 30. So I can create a ratio and solve it. So again, if I cross multiply 15 times 12 is 180. So I have 30x plus 30 equals 180. So 30x, if we take the 30 off of both sides, is equal to 150. Divide by 30 on both sides. We get x equals 5. Okay, which, again, makes sense. Look what we have. This side, this big long side is 30. This big long side is 15. That's a times 2, right? 15 to 30. Oh, this side is 12. So shouldn't this side be 6? If x is 5, 5 plus 1 is 6. 6 times 2 is 12. So 15 to 30 ratio, 6 to 12 ratio. They're the same. Okay. Please ignore that slide that keeps popping up. That's not for yet. All right. So now that you've enjoyed watching me battle with technology for 20 minutes, give that assignment a try. I will see you in office hours tomorrow. We can go over any of the problems that you feel like you need to go over. Hopefully you have already mastered the Quizlet set. If you haven't, make sure you get in there. I believe I made the due date on that Tuesday. So make sure you get into Quizlet and master that set. All right. See you later, crocodiles.